Okay, in this video we will show how to use Capstone software. So first we open the software and we will use the smart card as the instrument with which to take some data. First thing to do is, well, we don't have the key, so we close it. First thing to do is to go to the hardware setup. That opens the hardware setup panel and it's waiting for a Bluetooth device. So here we have the switch. We press this, the red light comes on, and now we get a flashing red light. So the Bluetooth is ready. It's sending the signal and it's detected it. So we collect this and it's connecting to the smart card. And it's going to take a minute or so to connect to the smart card. Okay, it asks for upgrade, so we say no, and now it will connect. Now the smart card has these 4 sensors. We'll turn off 3 of them and just leave the position sensor for the purpose of this demonstration, and then we click hardware setup again. That will close that panel. Now we go to sensor data and click that, and because we have a smart card which is it was set on the position sensor, it shows down here smart card position sensor, and it shows position on the y-axis, time on the x-axis. Now before we actually start data, let me you can see this little hand, and I click left click, it grabs this thing and I can pull it to the right, up and down. Okay, I can set it where I like, so I can do that. Second thing, I move it here and now it becomes a 2-sided arrow. I left click and I expand the scale, so the 2 seconds comes all the way up to here. Okay, I can expand the x or the time axis or compress it, and same, I move to the left, get a double-sided arrow. I can expand this and go to, if the velocity, if the positions are small, I can use that. If the positions are large, I can squeeze it out. So these 2 things, and move the whole thing as needed. Now when we want to start taking the data, we will click record. That will start taking the data, and I'll do that. Okay, and you'll see that starting taking the data, and it's not moving, so the position remains the same. I stop data and it stops over there. Well, this is delete last run. I will delete this case, and so that I don't need that data. And now we will do it again, and this time we will cause the card to move. Now, we will now start this, and I'll bring it to the left, and I'll push it so it's going to go to the right, hit this and come back. Or I can start from here and it's going to hit that and come back. So let's do it this way. So first I start record, and now I push it and I'll stop it here. Okay, so the position was 0. Then when I pushed it, there was some acceleration. Then it went with more or less a constant velocity, and then it hit the magnetic bumper here, and it started moving back. So this is the 0 position, and this is almost 0.2 meters, and then it comes back to the 0 position. Starts from 0, goes to 0.2, comes back to 0. Now if I want the slope of this line to get the velocity, I use this tool. I click it, it opens a little rectangle. I will bring the rectangle over to that part of the data over which I want to get the slope. Now if I keep it here, it's going to try to fix a straight line into all of that, and this is not a straight line. So I need to keep only that part of the data, okay, not this part, only that part of the data which I think is what in the area of interest. And then this tool gives me the equation. So if I click it, I get an option of so many different kinds of curves. We select the linear, click over here, that disappears, and now this fits a best fit line with a slope of 0.385 and a y-intercept of -0.56. So when this line goes down, it's going to intercept it at here, 0.56. 0.56. So that's how we can get the slope of this line. Now, in case it's not supposed to be a straight line, suppose it's supposed to be a quadratic, well, first we can right click and delete this and click here, and that's gone. So if it's not a straight line, for example, in this part we don't expect a straight line, it's not going to be easy because well, we can expand the data this way and this way. All right, so in this part it's going to be more like a quadratic because there was acceleration and we fit a quadratic curve to it, and you can see that's the quadratic curve that fits to it with the values A, B, and C. Okay, so now what else? We can get the area under the curve if we want. So we select a region and we get the whole curve. Let's say from here to here. What is the area under the curve? That's this tool, this one, and that is the area. Okay, now if we want to find the value of that point, then we use the coordinate tool, that's this one, coordinates tool, and we can bring it close and it will create an arrow that jumps onto it like a sort of a thing that sticks to it. So right now that's the value, 0.21 seconds, and that's the y value. So you can read it off from here, or you can use the coordinates tool and find the value at different positions. Okay, cross that out. There's also a tool for the slope. So if we use this tool, it's going to give us the slope at different points. Okay, so that's the slope here, 0.38, and now it disappeared. Okay, so we can click it again. Sorry, that's not the one. Slope tool. Okay, and you can get the slope here is 0.38, and that's the slope here. Okay, you can get the slope at different points. So that's cross it out, and this one can be crossed out. Okay, so these are some of the earlier things. Now, if you want to use find the velocity, you just change this to velocity, and that is the velocity curve. The x-axis, the x-axis changed a little bit, but you can see the velocity is positive and negative. Here the velocity is 0, so the velocity is more or less 0, and then it's positive and negative, and in that part it's increasing to that value and then decreasing. That's when it hit the bumper, and that's the 0 when it turned backwards. That's a positive velocity and then negative velocity, then a constant velocity in this part, and then, well, when I held it, we get that, and it stopped. We can also get the acceleration, and that is the curve for the acceleration. Now, if you want to do another run, all you do is record, and you can do another one. Okay, and you get another curve. And let's do one more. Okay, let's just move it around like this. So that's your curve, and you can find the slope or whatever. Now, to go back the previous one, you go to this tool, and run number 1, that was our first one. Run number 2, that's the second one. Run number 3, the third one. And we have all the data for that's run number 3, and run number 2, and run number 1. Okay, so we have all the data for position, velocity, and acceleration. It just keeps on adding them up, and you can go and delete some of them if you need to from here. If you want to delete run number 1, 2, or 3, or all of them. If you can change the rate at which the data is being transmitted. So if you do this experiment, well, that you may want a higher data record rate. Okay, so yeah, that's about it. We will look at some other things maybe as we go along. So we stop here, and to do that, well, you can also, one more thing, add a page and here you get another curve. Okay, and you can remove this and well, select the measurement, position and time, and we got that earlier thing. So we can take different pages. If you want to print it out, here's a title. You can type in the title of your report, take a screenshot, get a picture of this graph attached to your report. But before that, if you want to attach it to the to your report, it's good to get the slope or whatever is needed. Okay, and put that in a nice place. Okay, and then get a screenshot so that you have the data on the screen. And then when we're all done, we can just go and turn it off. Do you want to save the data? You can, or normally I just discard it. Okay, and Capstone is closed. Okay, so that's how we use Capstone.